Question number 4. If pth term of an AP is Q and qth term is P, the value of P plus qth term is, options are 0, 1, -1, none. We have been given pth term of an AP is Q. Let the first term is A and the common difference is D. Then TP will be what? It will be A plus P minus 1 into D, using the formula that nth term Tn is A plus n minus 1 into D. If A is the first term, D is the common difference. Then Tp will be A plus within bracket P minus 1 into D. As per question, pth term is Q, so this is equal to Q. First equation. Similarly, qth term is P, so TQ is equal to A plus P minus 1, Q minus 1 into D is equal to P. Second equation. Now we want TP plus Q. TP plus Q. This will be A plus P plus Q minus 1 into D. Here I am to put the values of A and D, which I will obtain from these two equations. Now subtract these two equations. A and A are cancelled. This is P minus Q into D is equal to Q minus P. Minus can be taken common, so it will be in bracket P minus Q. This gives us D is equal to minus 1, because P and minus Q and P minus Q are cancelled. P and Q are both not equal, so they can be cancelled. We obtain D is equal to minus 1. Now D is equal to minus 1, I put in the equation 1. So I obtain A plus P minus 1 into minus 1 is equal to Q. This gives us A is equal to P plus Q minus 1. Now value of A and value of D I can put here. So TP plus Q will be P plus Q minus 1 plus P plus Q minus 1 into minus 1. This is equal to P plus Q minus 1. Minus 1 multiplies this, so minus P minus Q plus 1. All are cancelled. This gives us, that is P plus Qth term is 0. Here our option A is the correct answer. Question number 5. The sum of first n natural number is. Sixth is sum of squares of first n natural number is. And question number 7 is the sum of cubes of first n natural numbers is. All are formula based. We know that first n natural number sum is denoted by sigma n. And this sum is equal to n into n plus 1 upon 2. So here option A is the correct. Sum of first n natural numbers is n upon 2 into n plus 1. Here option A is the correct option. Now sum of squares of first n natural numbers is, it is denoted by sigma n square. This is given by n into n plus 1 into 2n plus 1 upon 6. So option B here is the correct answer. Here answer is option B. The formula for sigma n square is n into n plus 1 into 2n plus 1 upon 6. Question number 7. Cubes, sum of cubes of first n natural number. We know that sigma n cube is given by n into n plus 1 upon 2 whole square. So here option C is the correct answer. Here the correct answer is option C. Basically all the questions are formula. We should remember them also, and we will be making use of these formula while solving the questions. Question number 8. The sum of a series in AP is 72. The first term being 17 and the common difference minus 2. The number of terms is, options are 6, 12, 6 or 12, none. We have been given first term is 17. So A is equal to 17. Common difference is minus 2. So D is equal to minus 2. Sn is given 72. Sum of first n terms denoted by Sn is given as 72. We have to find the value of n, that is the number of terms. Now we have the formula Sn is equal to n upon 2 within bracket 2a plus n minus 1 into d. Put the values. 72 is equal to n upon 2, 2 into 17 plus n minus 1 into d is our minus 2. Now 2 can be taken common, and which cancels this 2. So I am cancelling in this step only. Simplify. 72 is equal to n into 17 minus n plus 1, that is equal to 18n minus n square. This implies n square shifts here, so it is n square minus 18n plus 72. This is equal to 0. Now we have to factorize n square minus 18n plus 72. We want to have two numbers such that their multiplication is 72 and their sum is 18. Obviously, those two numbers are 12 and 6. Sum is 18. 12 into 6 is 72. So this implies, we factorize it, we split the middle term, n square minus 12n minus 6n plus 72 is equal to 0. N is taken common, n minus 12 minus 6 taken common, n minus 12 is equal to 0, which gives us n minus 12 into n minus 6 is equal to 0. That is, if first factor is equal to 0, then n is equal to 12. And if n minus 6 is equal to 0, we obtain n is equal to 6. That is, two values of n are obtained. One is 6 and second is 12. So here option C is correct, 6 or 12. These are two values of n, that is the number of terms of the series. Question number 9. Find the sum to n terms of a series is given 1 minus 1 upon n plus 1 minus 2 upon n plus 1 minus 3 upon n and so on. Four options are given to us. Now the series is 1 minus 1 upon n plus 1 minus 2 upon n plus 1 minus 3 upon n, and we want the sum to n terms. Now we can split the series. First term is 1 in each term. So 1 plus 1 plus 1 and so on to n terms. This becomes one series. Minus in second terms can be taken common. So it will be 1 upon n plus 2 upon n plus 3 upon n and so on to n terms. This becomes our second part. First part is this, second part is this. We have splitted the given series. Now 1, if it is added to n terms, this becomes n. If 1 is added 2 times, it becomes 2. 1 is added 3 times, it becomes 3. So if 1 is added n terms, up to n terms, it becomes n. Minus, now here n can be taken LCM, and we get the numerator as 1 plus 2 plus 3 and so on to n terms, which is sigma n. And we know that sigma n is 1 plus 2 plus 3 to n terms. It has the formula n into n plus 1 upon 2. So I can write the numerator as n into n plus 1 upon 2. So I am directly writing n into n plus 1 upon 2. So 2 will come here in the denominator. Now n and n are cancelled. So this becomes n minus n plus 1 upon 2. 2 can be taken LCM. It will be 2n minus n minus 1. Simplify, then it will become n minus 1 upon 2, which can be written 1 upon 2 into n minus 1, and hence our option A here is the correct answer. Question number 10. If Sn, the sum of first n terms in a series, is given by 2n square plus 3n, then the series is in, options are AP, GP, HP or none. We have the formula that Tn is given by Sn minus Sn minus 1. In AP, the nth term is given by Sn minus Sn minus 1. Now here Sn is given as 2n square plus 3n. So Sn minus 1 will be, I replace n here by n minus 1. So it will be 2n minus 1 whole square plus 3n minus 1. Simplify this. It is 2n square plus 1 minus 2n plus 3n minus 3. 2n square plus 2 minus 4n plus 3n minus 3. Simplification gives 2n square minus n minus 1. Now Sn, I have Sn minus 1, I have evaluated. So Tn can be calculated. So Tn is given by 2n square plus 3n minus 2n square minus n minus 1. Simplify, so 2n square and minus 2n square are cancelled. 3n plus n, because it is minus multiplied will become plus. So it will be 4n plus 1. Now nth term I have evaluated. So T1 will be what? N is put. N is taken as 1. So 4 plus 1, that is equal to 5. What will be T2? And I put 2, it will be 8 plus 1, that is equal to 9. T3 will be what? It will be 12 plus 1, that is equal to 13. T4 will be 16 plus 1, that is equal to 17. Now identify whether it is AP or not. So 9 minus 5 is 4. Again 13 minus 9 is 4. 17 minus 13 is 4. That is, we are getting same common difference. That is, we have used the formula of AP and we found that the series is in AP if the sum of first n terms of the series is given by 2n square plus 3n. So here option A is correct. The series is there in AP arithmetical progression.